Welcome to the Basic Electricity 2 Initial Testing course. The purpose of this lesson is to teach you what questions to ask when gathering your initial troubleshooting data. At the end of this lesson, you should be able to isolate a problem to a region of a circuit based on your initial indications, identify an uncontrolled energized component, and identify a blown fuse. When troubleshooting, it's tempting to start taking readings right away, but it's better to just set the meter aside initially. If you think about it, good doctors don't just start operating right away. They sit down and ask questions about your symptoms and then follow up with tests based on the information you give them. Likewise, good mechanics don't just start randomly replacing parts. Instead, they start the car, look, listen, and feel to determine where the trouble may be. Operating the circuits, especially those that have multiple inputs, will tell you a lot about which region of the circuit the fault may be located. When you're trying to gather information, there are a few basic questions you should ask. How should the circuit work? What are my flow paths? And how is it working now? Consider the following circuit block diagram. In this circuit, we have an independent DC and AC power source. When the control switch is closed, the DC power goes through the control switch to energize the DC coil of the relay. When this happens, the operator should hear an audible click as the AC contact closes. Once the AC contact closes, the AC power will be permitted to flow to the AC motor. At this point, the operator should see the motor spin and hear the hum of its operation. Now that we understand the operation of this circuit, let's look at a few rules for identifying a fault's relative location. First, if an end device is working properly, then the components upstream of that device are probably not the source of the fault. In this circuit, the end device for the DC portion of the circuit is the DC coil, and the end device for the AC portion is the AC motor. Second, if an end device is not working properly, then the problem is either in or upstream of that component. Third, some circuit components are independent in the sense that a fault in one part of the circuit cannot be caused by the other. While a fault in the DC portion of the circuit could prevent the motor from energizing, there is no fault in the AC portion of the circuit that could prevent the DC coil from energizing. So, if you throw the control switch and the DC coil doesn't energize, that is, if you don't hear the click, then you can devote your attention to the DC portion of the circuit. On the other hand, if you do hear the click of the relay energizing but the motor doesn't start, then the problem is in the AC portion of the circuit. With time and practice, you will learn to approximate the location of a fault based on the symptoms shown in normal operation. Let's say you've determined the region of the circuit where the fault is located. The next step is to identify the type of fault that you're dealing with. The two things that I'm going to show you at this point are checking for an uncontrolled energized component and checking for blown fuses. First, let's look at an uncontrolled energized component. If you open a control device and a component remains energized, then you have an uncontrolled energized component. In this circuit, opening the second switch will not de-energize the lamp, so we have lost our control over the component. An uncontrolled energized component is an indicator of a shunt, which we will discuss further in the troubleshooting shunts lesson. The second thing to look for is a blown fuse. The way to check for a blown fuse is to measure the voltage on both sides of the fuse. If the source voltage is measured on both sides, then the fuse is good. If you measure less than source voltage on the downstream side, however, the fuse is blown. The state of the fuse is a good indicator of whether you're looking for an open or a short. Generally, shorts blow fuses while opens do not. We will study this further in the troubleshooting shorts and troubleshooting opens lessons. Let's review. In this lesson, we learned how to isolate a problem to a region of the circuit based on initial indications, identify an uncontrolled energized component, and identify a blown fuse. In the videos that follow, we will delve further into the rest of the troubleshooting procedure and study the specific techniques for finding shunts, shorts, and opens.